Okay, so I'm gonna try to teach. Now I'm wearing a hat because first thing, uh, I don't wanna like when I'm looking down, my iPad's the only thing I see or my paper. So study method. Uh, this is a sample problem that Ma'am Tess did in the video. I just watched it and I kind of wanna like just record it so that like it sticks with me like what I learned. So here's a sample problem. In the common emitter amplifier shown, R1 is 50, R2 is 1K. Determine the quiescent collector current, which is ICQ. And ICQ is different from IC because ICQ is quiescent point, so it's like a middle point. That's a different thing from IC. Just side note. Okay, so find ICQ needed such that the unity gain frequency is 1 gigahertz and use CL equals 1 picofarad. So there are already given parameters. Beta is infinity, VA, which is early voltage, is infinity also, and we're also given C pi. Now, in the video I just watched, Ma'am Tess said beta being infinity means that we have. Okay, wait. Like it's a given. If that's given, we can ignore shit. Okay, we can ignore r pi. Yes, r pi is also infinity, meaning that it is short. No, it is an open. R pi is open, and then VA or the early voltage being infinity as well means that R out R out is also infinity, meaning that it's also open. So when we draw the small signal like circuit, it's it's not there, it's open. So the first thing that she did was, okay, let's redraw the circuit first because I think that's important. R2 with the values 1k ohms connected to the CL capacitor. I guess it's like a good thing to know what you can ignore if it's not given, because usually in triple E they will give you values and sometimes you might think you're gonna be like, oh, okay, I don't have to use this value, but it's weird that it's there. Your answer is wrong. That's what in my life experience. So this 50 ohms. Okay, this is R1. Ayun. First thing we want to do, draw this first, this BJT. So when we draw the BJT, small signal, it has VBE. It also has V in. So let's draw this. Let's green. Yan. This portion muna of the BJT. So I'm gonna draw it. Uh, emitter is to the ground. So that's emitter. And then imagine may 0.7 na VBE. And how do you get that 0.7? With a resistor. Okay. And then connect that. Mamaya na yun. And then there is also current coming from IC here. So you have a current thingy here. Tama ba? Yes. Yeah. Okay. Let me reflect. R. This is not a resistance. Wait. C pi is 50 femto farad, or the same thing as 50 times 10 raised to negative 15 farads. Mamaya na yun. Okay. Capacitor. Yeah, okay. Because we say that R pi is infinity. So R pi is usually here, pero short siya. So mawawala yun. Yeah, because there's a resistor. That resistor that I was talking about earlier. Because like if you imagine, how do you get from V in to 0.7 na deduction? Obviously, there's like a hidden resistor there. Because like how can you get that reduction if this is just your, if it's just like the BJT alone? How do you get that 0.7 reduction? So in small signal, that reduction is R pi. But since beta is infinity, that means R pi is infinity, meaning that's open. So we ignore that. So it's not there. And now we can add 50. So let's just label that as C pi. Yes. Okay. Yeah. Okay. This is the BJT, that green box that I drew, GMVBE. And I don't know, like you just know that it's GMVBE. So parallel sila, that's also VBE. Just like if you don't want to memorize it, like if you don't want to memorize the figures, that's my logic and like how I remember it. So next we're gonna draw, there's a resistor attached to it which is 50 ohms, and then V in. So that's the, this portion is the BJT. Let's, okay, let's draw that red box just so that it's easier to look. Now connected to that, so this is collector, this is emitter, this is the base. Yes. Okay. Connected to the collector is R2, which is 1 kilo ohms. And also a capacitor, which is 1 picofarad. 1k ohm, 1 picofarad. Pico is 12, so 1 times 10 raised to negative 12 F. And then may V out. V out. Now usually, may R out rin here. But since again, VA is infinity, we neglect R out, or it's open. So wala yun. Mawawala yun. Okay. Yeah, that's the rest of the BJT. Let me just copy, because I'm gonna proceed to the next. Ayun. Now, what are we looking for talaga? Determine quiescent collector current, ICQ, needed such that the unit. So now we already set up our small signal like circuit. First thing I want to do is like set up equations. So we know, like without looking at this first, we know that the gain, the magnitude gain is V out. I know it's V out over V in. Yeah, V out over V in, but specifically when current, no, V out over V in. Wait, let me. Okay, doesn't say anything. But usually there's like a condition, so like I out equals 0. But Ma'am Tess didn't mention that. Pero ganyan na rin. V out over V in. And then we want to set up our equations. So let's do KCL. KCL, different kinds of KCL at V out. So V out, we have going here and going there. And you can see that these two are in parallel. So the conversion is in frequency response, capacitors are 1 over JWC. And in this case, it's 1 over JWC is 1 times 10 raised to negative 12. Okay? And then now we're gonna do parallel resistor stuff. So 1K parallel JWC times 10 raised to negative 12 equals to 1,000. Diretso na to. JW 1 times 10 raised to negative 12. Inverse the inverses. So inverse it just in case you forgot, inverse it on its own, add that, and then inverse the whole thing again. So, we're gonna multiply 1,000 to 1 times 10 raised to negative 12. I realize, wait, positive 12 to. Yeah. Pero we're gonna inverse it again naman later. Tama ba? 1 times 10. If you're not sure, just put it in the calculator. Tama. So, when we inversed it, positive siya. Times 1,000. So, 1 times 10 raised, parang may mali. 1 over JWC. Magiging pico. 12 or 15. Pico is P. Negative 12. If I inverted it, ba't ganyan? One over JWC. Inversing. So, dapat negative ba siya? I guess. Negative 12. So that when negative 12 times 1,000, 1 over JW, what did ma'am test do? Ba't positive yung... Wait lang ah. One over JWC. Negative. And then when you inverse, it keeps its value. Sorry, my bad. Inverse of the inverse. 1 times 10 raised to negative 12. If you're confused. Okay. 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 Times, so that 1 times 1,000. It's 10. 1 times 10 raised to negative 9. Yeah. Okay. Sorry. Had to double check. Because I forgot that this is like that. You can inverse that. It's still the same. Okay. And then we inverse the inverse. So, 1 plus. Yan. Totoo na to. Totoo na to. 1 times 10 raised to 9. 1,000. Yes. Okay. So, that's the... It's like the resistor value. And I'm gonna redraw it lang for KCL. So let's just say we have that and then some other shit. There. Ayan. So that's 1,000 over 1 plus JW. 1 times 10 raised to 9. Tapos V out. V out. KCL. Palabas ng node na to. Because this is the V out node pa rin. KCL at V out equals to I1, I2. Ayan. I1 is just V out over the resistance, V out minus 0, para complete. 1 plus JW time 1 times positive 9. Okay. Plus I2, this is GMVBE, plus GMVBE. Again, I in equals to I out. But since everything is just out, equals 0 yun. Yeah, everything, let's make everything out of the node. It's all equal to 0. Now, let's just remove that. Just for the formality, I just added that there. In case na this isn't a ground. Basta you know na you have to, wala lang, very detailed talaga to. Okay, so, VBE is the same thing as something that we would compute here. Kasi we need VBE for something later. Okay, VBE is here. Wala lang, it's more like reducing terms. So we do another KCL here. Another KCL at this segment. Ayan. KCL at... no. My bad. Voltage division. For VBE. Yeah, tama. VBE. Again, may resistor. May capacitor. Tapos ground. The value of C pi is 50 femtofarad, or the same thing as 50 times 10 raised to negative 15 farads. And then this is 50 ohms, then this is V in. And then there's no given value for both. So just do the voltage division with just the variables. Yes. So, again, C pi, 1 over JWC. Input mo na lang yung C pi there. So, VBE is V in, so voltage in multiplied by the resistors. So, it's the total resistors, the total resistance of that series, 50. Yun. And then on top is the one that, the resistance of the one that we want. Ayan. A lot of elements here. I'm just gonna simplify it quickly. V in. So, 50 times 10 raised to negative 15 times 50. And then we get JW times 2.5 times 10 raised to negative 12 plus 1, because of this, over JW 50 times 10 raised to negative 15, over, that one is over this thing, 50, 10 raised to negative 15. Ayan. So, pwede na i-cancel to. This and this. And then we're left with VBE equals V in multiplied by JW 2.5 times 10 raised to negative 12 plus 1. Ayan. Yes. Yeah! And then now, this one we can substitute here. Oh my god. 1,000 1 plus JW. Actually, there's a better way of writing this. V out divided by. So, V out multiplied by 1 plus JW 1 times 10 raised to 9 over 1,000. Yes. Multiplied by GM and VBE. So, JW, the VBE that we just got earlier, 2.5 times 10 raised to negative 12 plus 1. Ayan. I'll just move the 0 here. Now, what's the next thing that we need to do? My bad, may V in pala to. Now, we have two elements. We have V out, V in. Now, we can, like, get na. We can, like, basically get the gain. So, what I do, V out. Let's move it to one side. Ayan. Copy ko lang. And then negative, V in. Basta isolate lang. Ayun. Because we want to get the gain. And is 12 plus 1. GM. Okay. V out over V in equals to negative this one. Let me just para easier to see. Ayun. Okay. Let's just copy the old stuff. And then multiplied with 1 plus JW, 1 times 10 raised to 9. Ayun, 1,000. So now, we have our gain, but we can also see that these are in the form of these denominators, 1 plus J omega over WP, some pole, and then another na pole rin. Not yet gonna label these poles kasi we want to observe muna what's the smaller pole. So the smaller pole is 1 times 10 raised to 9. Let me just double check. Negative pala yun. No, positive. I can't even understand my own handwriting. Negative. This is negative 9, my bad. Yeah, okay. So the pole of this WP something is 1 over 10 raised to negative 9 or 10 raised to 9 10 raised to 9 rads per second, which is also the same thing as 1 gigarad per second. And then to get the frequency, this is, by the way, this is smaller, the smaller pole between the two. So yun yung in this graph, if we do the graph, WP1 is always first, then WP2. So we choose the smaller one because that's the one that, oh my god, that's the one that is gonna hit first in x-axis, y-axis. So yun. To get the frequency, just divide W with 2 pi. Where's my calculator? 1 divided by 2 pi. Yes. So we get 159 point, how many decimals? Okay, 1 decimal. 2 megahertz. Ayan. And then we can get rin WP2 here, which is 1 over 2.5 times 10 raised to positive. Wait. Yeah, 1 over WP1. 2.5 times 10 raised to negative 12 equals to 4 times 10 raised to 11 or 400 gigarad per second. WP2 yun na. And then the frequency of P2 is 63.7 gigahertz. Again, it's just the same na you divided it with 2 pi. Now, we also know that the magnitude gain is 1,000 GM. Kasi of this and this. Okay. Next. Ayan, okay. Sorry, I keep saying that. The gain that's not magnitude yet is negative 1,000 GM. And then we also have yung previous values here. So, let's just use F. Kasi, alright, F unity is 1 giga F unity is 1 gigahertz. And that's a frequency. So we're gonna compute stuff in frequency. If it was given in omega, yung W, that's rad per second. So you're gonna use the WP1 and WP2. But then FP1, we know it's 159.2 megahertz. And then FP2 is 63.7 gigahertz. So we're gonna do, wait, first note, F unity is smaller than FP1. I guess that's like important to know for the GBW, which is the gain bandwidth product. Ayan. And we're gonna do the magnitude graph. So AO, which is V out over V in, as mentioned earlier. And in this side, pag ganyan, usually yung side na to, the y-axis is 20 log AO. You have to remember this. And then this one is log F. So here, 0 decibel. This side, y-axis is in decibel. And when we graph this pala, again, note na may F, well, W. They use W. WP1, W unity. Usually ganyan, pero I forgot frequency nga FP1, F unity, tapos FP2. F unity is 1, and what happens is we're gonna graph from here until we reach this. So constant siya, and then we go all the way down, and our slope is negative 20 decibels per decade. Yun, per decade. And then after, when we reach FP2, when we're going down, and down ulit, it's gonna change trajectory ulit. So, it's like physics. Ayan. You can't really see it, pero, yan. Negative 40 decibels per decade naman yun. Pero what's important for us to know is like this portion, because in gain bandwidth, this is your bandwidth. Yeah. And we just want to know like this segment. Basta yun, yung segment na yun. Okay. Now, let me just, the unity gain, if it's W, is AO WP1. But since we're working with frequency here, again, W is 2 pi F. So, magiging 2 pi times FU. And then gain multiplied by 2 pi times FP1. But then since may 2 pi na both sides, so frequency unity is just the gain times FP1. And we know this. Yes, we know both of those. I know. Yeah, we know both. We also know this. But then, okay. Yeah. We know them all. But then we're looking for like a specific value. We know the numerical value of this. Kasi gain nga siya, unity gain. And then AO, magnitude. So let's just put that first. 1000 GM from this previous thing. We already computed that. Multiplied with FP1, which we got earlier, 159.2 megahertz. Ayun. And then GM is just, if you compute it, 6.28 ms. Siemens, I don't know, Siemens, yun. And then ICQ, did we get this earlier? Oh, I didn't mention the formula for this. Okay. When we derive, we know that GM is equal to ICQ CQ over VT. No, baliktad. GM is VT over ICQ. But then we are looking for ICQ. ICQ. Wait, hold on. No. ICQ is GMVT. But then we got that from GM equals to ICQ over VT. Okay, you have to remember this formula talaga. Transconductance. Period. We're getting ICQ. So ICQ is GM, which is 6.28 ms, times VT, which is 0.026 volts. Okay, wait. Ayun. Okay. Then we get ICQ equals to 0.163 milliamps. Ayan, charan! Medyo mahaba yung explanation pala. But it's like that. That's my thought process. Ayan. Okay.